Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 6.2.10 on matrix inverses. Okay, so when we were talking about determinants, we were talking about kind of a pairing idea, or kind of like a dot product, so multiplying certain determinants on one side with determinants on another side, or rather just values from an input with determinants in a base over here. And sometimes dot products are zero, especially if we repeat things. And sometimes we actually get the determinant, or maybe a sign of the determinant. We can kind of finagle that a little bit to get a matrix such that if we multiply it by itself, no, a matrix so that if we multiply it to the original matrix, we end up getting the identity matrix. What is the identity matrix? This is the identity matrix right here. So like start with this matrix, multiply it by another one so that we get this one. Well, we can kind of finagle this dot product idea of indeterminate land. Like if we dot something with a base thing, sometimes we get 0, sometimes we get 1, in order to kind of see what we need over here to multiply by to get this. Because remember, in matrix multiplication, we could really just say this dotted with like the first column to give you that, and then this dotted with the second column to give you a 0. So that's the basic idea. If you read through this little subsection, that's the gist of what's really going on. We're just kind of playing with things to trying to figure out what to put in our different rows or columns so that when we multiply using the determinant idea, we either get the actual determinant or 0. And then we just divide by that determinant to get us ones. And that's kind of the basic idea. So if you look through this runs through some specifics and details and ways that you can kind of think about this and to even kind of develop it. So right here, actually, we developed our matrix here by rows. And notice how we're dividing by 1 over a determinant of some permutation of the columns. Times these specific rows, which we came up with. These rows are actually rows of determinants from a certain base, like a choice of columns, and we're looking at determinants, 2 by 2 determinants in there, and then we're kind of be dotting it with maybe like this. And so if this actually was in the columns that we were taking determinants of, we're going to get a 0. And if it's not, then we'll get a 1. And that's kind of the idea that we use as we move along here. Okay, and right. Okay, so here's the actual inverse and multiplied, and we can get that. So this runs through another little demonstration of that. So again, read through this to see the specifics, but that's the gist of how it works. You can actually notice how we're looking at different places, like this place, or this place, or so, and see the reds that are offset from it that are not in the same row or column. Actually, if you take a determinant of those, you take a determinant of those guys right there around this green position. That determinant is, so if we take a look at the, notice that was a -3 goes in the inverse, and a -3 was the determinant of this part right here, 5 minus 8. Okay. Now also notice that there's we're associating a plus with this guy, and along the way there's different places where we put pluses and minuses. And just a minute here. And if we look at this plus minus right here, that actually kind of gives us an idea of where to put a plus or a minus. That comes from the permutations involved in deciding on those specific determinants. involved in getting that. Now it's not simply okay. So now let's take a look and just see where this -9 comes from right here. Okay. Okay, so -9 actually comes from right here, from this determinant, from this place. Notice, but that 3 is up there, and this -9 is over here. Why is that? That's because after we do this, we actually send them to see. We change our perspective of columns and rows. This is the second column. Well, whatever we find out in the second column, then we put it into the second row of the inverse matrix. So that's kind of one thing to think about, especially since you could think about matrix multiplication as a dot products as we move along. So that's a and here's an example where we can do it for a 2 by 2. I encourage you to look through that. It's the same basic type of idea. Just kind of gives you an overview. In fact, here's even a formula for the inverse of a 2 by 2. Okay, so here's an example that actually runs through it. You can take a look at that one. And then here's another way we can find inverses. We can take a matrix and we can just do row operations to it. And if the row operations end up taking us to the identity, then the matrix that represents all the row operations, that isomorphism itself, as written as a matrix, is actually the inverse. So we could actually figure out what the inverse is by looking at what the different row operations are, and then putting all those row operations, just doing them on the identity to see what the resulting cumulative matrix is, and that what we actually get right here is actually the inverse of the matrix. So that's another way of doing it. There's multiple ways of figuring out inverses of matrices. Again, that's just they're multiplicative inverses, so the thing we have to multiply by to get the multiplication inverse. The multiplication inverse, at least for 3 by 3 matrices, is this one. You can check that. If you multiply a 3 by 3 matrix by this, it gets back to itself. Thanks for watching.